Assalamualaikum and good days to everyone. My name is Mustafa LUTFI bin SABAR. So today I want to do some presentation on learning how to solve problems involving linear motion under 15 minutes. So with that, I hope you guys can enjoy my video and gain valuable lessons. And let's go. So as I mentioned in the title of my presentation, the my learning standard is on 2.1.3, which is the solve problems involving linear motion using the following equation. We have four equations. The first one is v equals to u plus at, and the second one is s equals to half u plus vt. The third one is s equals to ut plus half at square, and the last one is v square plus u square plus v square equals to u square plus 2as. How not recap, I mean, how do we get all this equation? So let us look at one by one. So the first equation, it is based on the acceleration. So we know that acceleration is the final velocity minus initial velocity over time. And so we can arrange this equation in in this form. And it's basically, the first equation is quite simple, so to make it more easy to understand, so we make it u plus at. So this is the derivation of the first equation. Next, we go to the derivation of the second equation, which is based on the displacement, the equation of displacement. So the equation of displacement is s, which is the displacement, equals to the average velocity times the time. And so we can expand the formula, the formula of average velocity into v plus u over t, where it is the final velocity plus the initial velocity over 2 times to the time. So and then we can arrange this equation into the final form, which is the 1 over 2 v plus ut. And then we go to the derivation of the third equation, where the third equation is we got the third equation by substituting equation 1 into equation 2. So this we have the first equation, v equals to u plus at, and then we have the second equation, s equals to half vu plus t, v plus ut. So and when we say that we want to replace to substitute equation 1 into equation 2 at the v place. So we see that in equation 2 there is v in the bracket, v plus u. So we replace that v with the equation 1 with the u plus at. So then we got the s equals to half u plus at plus ut. So and then we factorize all it, and so we got this the s equals to 2 ut plus at square over 2. So to make it simple, we can further factorize it into the final form of the equation, which is s equals to ut plus half at square. So this is the third equation of the linear motion. And then the last equation, the fourth one, is simply just by we squared the first equation. So we have the v equals to u plus at, so we square it, then we got v square equals to u plus at square, and then we can expand it, and so we got v square equals to u square plus 2 uat plus a square t square. So and then we factorize the second and the third terms into this in the bracket. You can see in the bracket. So as you can see, the all the terms in the bracket are very familiar, which is they are the equation 3, from equation 3, ut plus half at square. So we can for equation 3, which is the displacement s, so we can replace all these terms in the bracket into s. So we got the fourth equation, v square equals to u square plus 2as. Okay, so now let us proceed to do some problem solving. So let's look at the first question. Okay, so for question one, we have a sports car or a normal car, anything, that is moving at 40 meter per second. And then after 3 seconds, the car accelerated and its final velocity is now 50 meter per second. So we need to find the displacement. How far has this car traveled under 3 seconds? And the tips to answer all this kind of this linear motion problems is when we read the question, we need to list all of the information. So we have five physical quantities regarding linear motion. So we need to list them all: initial velocity, final velocity, acceleration, time, and the displacement. So we list all the five quantities, and then we look at the question. What information do we have? So we have initial velocity. Yes, we have 40 meter per second. And then we have the final velocity, 50 meter per second. Do we have the acceleration? No, we don't have the acceleration, but we can find. So because it is very easy to know the acceleration. And then we have the time taken, 3 seconds, and the displacement, which is what the question asks us. So from all the four equation, which one should we choose? So let's look at what information do we have. So we want to find S. So we want to find S. So we choose equation 2, 3, or 4. And for equation 4 and 3, we need to have acceleration. We can find acceleration, but if you can look at equation 2, there's no need to use for acceleration. So we can just simply use equation 2 to solve this equation. So we write equation 2 first, and then we just put in the value for each component. So we replace initial velocity with 40 and final velocity with 50, time with 3, and then boom, we get the answer for question 1. The displacement is 135 meter. And then let's go to question 2. For question 2, we have like an athlete ready to run. But so he didn't, for now he is still not moving. And then he start to run, and after 8 seconds, this runner reach his maximum velocity that is not mentioned. So okay, we don't have it is just mentioned the maximum velocity, but not mentioning what is the final velocity. And we have another information, which is how far has this runner run, which is for 40 meter. So under 8 seconds, this runner has moved 40 meter. So the question is, what is the acceleration of this runner from 0 to maximum movement speed under 8 seconds? So again, we list down all the information needed. So we list all the five quantities. Initial velocity, we have 0 because he start from stationary. And then we have the final velocity. We only know it is maximum, but we don't know what is the value. And then the question acceleration. So we need to find out what is the acceleration. And we have time, 8 seconds, and the displacement, 40 meter. So when we have all these four equation, all these four information, let's look back at the equation. So we want to find A. We want to find A is either equation 1, 3, or 4 we need to use. And for equation 1, we don't have the value of final velocity, so we cannot use. Equation 2 is already gone. And we have equation 3 and equation 4. But equation 4 still need to have the final velocity. So the answer is we need to use equation 3. Okay, so let's write the equation first. S equals to ut plus half at square. So we replace all the value with what we have. So we have 40 for the displacement, and then because the initial velocity is 0, so ut is already cancelled. We already replace it with 0, and then we have half a t square. So we want to find a, so the t time is 8 seconds, and then so we do some calculation. So we got we can arrange it to find the acceleration to 80 over 64, and we got the acceleration is 1.25 meter per second. So that is the answer for question 2. So now let us look at the last question, question 3. In this question, we have a boy riding his bicycle at 8 meter per second, and then suddenly he hit the brake and becomes stationary, or I mean like full stop, after traveling for 2 meter. So the question is, what is the boy's acceleration? So as usual, we need to let out all the information that we have. So we have the initial velocity 8 meter per second, and then the boys hit the brake, so the final velocity is 0 meter per second. And the question is acceleration, so we don't have acceleration, and we don't have time. And the last information that we have is the displacement, which is 2 meter. So which equation should we choose? So we want to find the acceleration. It's either equation 1, 3, and 4, but we don't have the time. So equation 1 and 3 it cannot be used. So the answer is we need to use equation 4. Okay, so first we write the equation. V square equals to u square plus 2as, and so we replace with what value we have. We have v square is equal to 0, and then we have 8 square plus 2a s. The displacement is 2 meter. So now we do the calculation first. So we got 0 equals to 64 plus 4a. Then we can arrange it so to find the acceleration, and then we got the acceleration of this boy riding his bicycle is negative 16 meter per second square. So this negative means that this boy is actually having a deceleration of 16 meter per second. So that is how we solve problems using the linear motion equation. Now let us do a reflection or a recap on what we have learned today. Today, first we learn how to do the derivation of the all the four linear motion equation, and then we learn something that first we need to let out all the information before we start to answering, as this will make answering or solving the problems easier. And then based on what information we have, we can identify which equation that is suitable to use to solve the problems. So, and lastly, uh, overall, we have learned how to solve problems using the four linear motion equation. So before I end my presentation, I would like to give one bring home question to you all that you can try by yourself. The question is not that hard. It's like basically the same like we have been answering the three questions just now. So like we have Aina rides a smart personal transporter at the Perdana Botanical Gardens, and the transporter accelerates uniformly from velocity of 1 meter per second to a velocity of 5 meter per second. So we have the initial velocity, and we have final velocity, and we have the time. So the question is to calculate the displacement. So I give the four linear equation motion and the linear motion equation as your guidance. So I hope you guys can try this question, and I believe you all can get it right. Okay, so with that, thank you for listening to my presentation, and have a good day. Thank you.